Yeah. Okay. Jiawen and Cliff are co-founders of Kaizen Operations LLC, a high-powered operations outfit, and we were engaged to optimize the revenue at Littlefield Corporation. So to maximize revenue at Littlefield, you would have to sign up for contract number 3, which costs $1,250 with a max lead time of 1 day. Purchase 6 stuffers, 3 testers, and 3 tuners. Set your reorder point for continuous review at 5,040 kits and reorder quantity ROQ of about 19,645 units. With this, an ending cash of $1.5 million is expected, as our simulation showed or shows below. So in the snip below are the different steps we implemented. For each of these steps, these factors shown above play a key role. Realized stockouts are expensive and tried our level best to avoid such situations. Utilization was important too. We need enough machines to ease traffic through the system and avoid bottlenecks. And last but not the least, cost. Careful selection of reorder quantity at an optimal cost to keep fuel rates as high as possible was key. So during the simulation, instead of going with our gut feeling, we made economic quantity or EOQ and ROOP calculations. For our inventory, we used the average usage of inventory in the EOQ model to find a reorder quantity of about 19,600 kits, and also use this amount for most of the simulation. Similarly, we use the reorder point calculator to find a reorder point of about 5,040 kits. As the inventory graph on the top right corner illustrates, this reorder point is very good and prevented stockout situations.
So here for the utilization analysis, we found that our utilization has a very high variance. On average, they're at a healthy utilization level of 57, 50, and 32% respectively. Also, during the simulation, we tried to add one more machine to station 1 and station 3 to lower the variance, but it doesn't seem to work. So it is possible that changing the queuing method can make a positive effect, but we didn't try that in our simulation this time. And finally, on the revenue analysis, overall, we have a very good average. When we started the simulation, we didn't make immediate change. Around day 100, we spotted that our revenue are capped by contract 1. So we changed to contract 2. We didn't stay in contract 2 for a long period because we see that we have an average lead time that's lower than 0.5 day. However, when we change to contract 3, our earning fluctuate wildly. As the graph shows, we even have days that have an average of around $160. So although we are yet to find out the reason of this fluctuation, we end up with a good revenue average, since the ending average is $1,030 per day, which is larger than 100. We can say that it is profitable for us to move from contract 2 to contract 3 because the cap of contract 2 is $1,000. So before the simulation ends, we have our last decision to make, which is to stock up the inventory. Here, we use the news vendor model to calculate the amount we need. We calculate the underage penalty by using our past revenue data, and the overage penalty is $10 per kit. Well, we put that into the model. So through the model, we have this inventory level of 862 batches of product that we need to stock up until the end of our simulation. We apply this number to our simulation and we end up with 4,320 kits left in hand. This might not be the perfect number since we want it to be closer to 0, but in our opinion, this is a very good result.
So in conclusion, we would suggest that in the future, the factory go with the contract number 3, purchase 5 stuffers, 3 testers, and 2 tuners. Stay at a reorder point of 5,040 kits and reorder quantity of about 19,600 units. If possible and cost-effective, try to relocate the bottleneck from station 1 to somewhere downstream of the system. And lastly, find a way to lower the overall variance in the product lead time.
So for our SWOT analysis, this strategy is feasible and efficient considering the high revenue, low lead time, and the good reorder point and quantity. However, there's a weakness of high variance, which could have a domino effect on lead time and revenue, but must be eliminated at all costs. We didn't have enough time to explore the solution for this threat yet.
So thank you for your time, and we'll be happy to address any questions that you have, Professor.